I want you to read these 5 situations and draw free body diagrams for each. Okay, so let me draw the first one for you and then you can try the rest. Let this horizontal line be the top of the table and the box is placed here. The free body diagram shows all the forces acting on it. First, there is a force of gravity acting on it. It will be downwards. And then there's a normal force acting upwards. As the forces are equal and opposite, the box does not move at all. It continues to remain at rest. And also notice that the size of the arrows is the same. The forces are balanced and the net force is 0. Now why don't you try drawing the free body diagram for the second situation? Read it well. First things first, the force of gravity will exist and pull the box in the downward direction. As it's placed on the table, there will be an equal and opposite normal force acting upwards. Now we come to what's written. A rightward force makes the box move across the table with rightward acceleration. The word acceleration is very important here. It means the velocity is changing, and the fact that the velocity is changing implies that the forces on the box are unbalanced. The upward and the downward forces net each other off. What about the leftward and the rightward forces? Now because there is a rightward applied force, we show an arrow towards the right. Will there be any leftward force on the box? As we've been asked to ignore air resistance, it will only be the force of friction acting towards the left. And because the box is accelerating towards the right, it means that the force of friction is lesser in magnitude than the applied force towards the right. And hence the size of the arrow of the applied force is bigger than that of the frictional force. The third situation is extremely interesting. Try making its free body diagram. It says that the box is moving at a constant velocity towards the right. In any case, there will be the gravitational and normal forces acting on the box. But this time, the applied force and the frictional force will be of the same in magnitude. Hence, the size of these two arrows will be the same. As the net force is 0, the body will continue to move at that constant velocity. And don't forget, we've been asked to ignore air resistance here. Now, would you like to try drawing the free body diagrams for the fourth and the fifth situations? In the fourth case, let us first discuss the forces that are acting on the skydiver. There will be the force of gravity which is pulling the skydiver down. As there is no table or ground, the normal force will not exist. And there's no applied force on the skydiver either. But as the skydiver is falling at a constant velocity, it implies that the net force must be 0. Which is the force that will net the force of gravity? Yes, it will be the air resistance. As the velocity is constant, it implies that the magnitudes of these two forces are equal. This is the free body diagram of the fourth situation. I want you to get the fifth one right now. This is how it will look. As it's free falling, it means it's accelerating. So the magnitude of the gravitational force will be more than the magnitude of the air resistance force. With this, you've understood the basics of forces.
Free body diagram. Free body diagrams are pictures that show the size and direction of all forces acting on an object. This simplified diagram allows better understanding of how forces are affecting a structure. Steps to drawing a free body diagram. First, pick one object to analyze. Second, draw a box to represent the object. Third, draw an arrow to represent each force acting on the object. Lastly, make sure the arrow shows the direction and relative size of the force.
How do things move in real life? Say a ball is moving on a flat ground and there's no external force acting on it. Will the ball eventually come to a halt? Yes, it will. Have you ever wondered why? Say you're skating on an ice rink and your friend is skating on the road. Whose movement do you think will be smoother? Definitely yours. When you hold a bottle in your hand, why doesn't it just slip through and fall? Sometimes when you're walking around in a mall, do you remember seeing a caution sign to warn you about the floor being wet? What explains all this? The answer is friction. The reason why the ball eventually comes to a halt is because of the force of friction. The reason why skating on an ice rink is easier because the force of friction is lesser there. The bottle doesn't slip through because the force of friction between your hand and the bottle doesn't allow it to do so. If the floor is wet, the friction offered by it reduces and there are chances that you might slip and fall. So what is this friction we're talking about? It's quite easy to understand its concept. Friction is nothing but a force. It is the force exerted by a surface where an object moves across it. In the first case, when the ball is moving in this direction, the force of friction is acting in the opposite direction. The force of friction offered by the ice rink floor is lesser than the force of friction offered by the road. Hence, skating on the ice rink is easier and seems effortless. The bottle does not slip down because the surface of your hand offers a friction in the upward direction. And in the case of the floor in the mall, the soapy water reduces the friction offered by the floor. In the coming lessons, we'll learn a lot more about friction. We'll see the factors affecting friction. We'll understand if friction helps us in our everyday life or not. And we will also cover the different types of friction. Here's a cube that's placed on the table. We know that if we are pushing the cube in this direction, then the force of friction will act in the opposite direction. If we apply a force along the left, then the force of friction will act towards the right and vice versa. The force of friction will always oppose the applied force. What are the factors that affect the friction? Let me give you 3 situations and then you tell me what it depends on. The first situation is when an object with a smooth surface is moving on a surface which is very smooth. Second, in which the object has a smooth surface and the surface on which it moves is rough. Or the object has a rough surface and the surface on which it moves is smooth. And in the third case, the surface of the object as well as the surface of the table is rough. In which situation do you think will the force of friction be the highest? Intuitively, you will tell me that in the third case, the force of friction will be higher than these 2 cases. And in which situation will the force of friction be the lowest? It'll be the first case as both the surfaces are very smooth. Though there will be friction here, it will be lesser than that in the other 2 cases. If we just look at these 3 situations, we can say that the force of friction increases as we go towards the right. So can you tell me the first factor on which the force of friction depends? Yes, it depends on the nature of the surface on which the object moves and the nature of the surface of the object. Yes, it depends on the smoothness or the roughness of the 2 surfaces which are in contact with each other. If you want to find out if this is true, here's what you can do at home. Create an inclined slope on a table like this and mark a point somewhere on it. Now from this point, let a small cylindrical shaped object move down. You will see that it reaches a particular point and then stops. Next, place sandpaper right under the slope and leave the object from the same point as before. What do you notice? You will see that the distance covered by the object is lesser in the second case. And you probably know why. The surface on which the object rolled was rougher in the second case. And clearly, the force of friction was more. Why is friction caused though? It is caused due to the irregularities on the 2 surfaces in contact. What do I mean by irregularities? Now, even though the table looks smooth, if we zoom into the surface, we will see the surface irregularities. Even the surface of the object has irregularities. Though they are minor, they still exist. Now the irregularities on the surfaces lock into one another. So whenever we have to move an object, we need to overcome the irregularities. But why is the friction higher on rough surfaces? It's because rougher the surfaces, more will be the irregularities. And if the irregularities are more, then more force will be required to overcome them. So the first factor affecting the friction is the nature of surfaces. Is there any other factor you can think of? Let's say there are two bricks on a table. One weighs 2 kilograms and the other weighs 5 kilograms. Now I apply equal force on them towards the right. Which brick do you think will go further? Remember that they are both kept on the same surface, and the surfaces of the bricks are also the same. On applying the same amount of force, you will notice that the lighter brick covered more distance than the heavier one. What does this tell us? It tells us that the friction also depends on the force with which the two surfaces are pressed together. If the two surfaces are pressed harder, the friction will be more. Why is that? Because of the second brick's greater weight, it presses on the table with greater force. Since its surface and the table's surface are pressed together harder, the interlocking between the irregularities is more. And this results in more friction. So mainly, there are two things on which the force of friction depends: the nature of both surfaces and the force with which the two surfaces are pressed together. I ended the previous lesson with a question. I asked you if the force of friction comes into play only when the two things are in relative motion. Let's discuss this in detail. Let's say you want to move the stationary sofa in your living room and the sofa is really heavy. What happens when you give it an initial push? Yes, you're right. Nothing happens. The sofa doesn't move even though you're applying a lot of force. Why do you think the sofa doesn't move? Well, the answer is static friction. The force that you apply is balanced by a frictional force by the floor. And this force is applied in the direction opposite to your push. This force is nothing but static friction. The concept of static friction is really amazing. Why do I say that? The reason why I say that is because it is a self-adjusting force. As you increase your force of push, the force of static friction increases too, and the forces are still balanced. Now I know what you must be thinking. After a few seconds, the sofa begins to move, right? What happens to the static force then? Let's discuss this with the help of a simple graph. We assume that the force you apply is the horizontal force represented by the x-axis, and the frictional force applied by the floor is represented by the y-axis. Now, as you increase the horizontal force applied, the frictional force is also increasing accordingly to keep the sofa at rest. This continues till a point where the sofa just starts moving. And that's where the static friction ends and the sliding friction begins. The sliding friction is more or less constant if you notice. This part of the graph is static friction. It's when the sofa is not moving in spite of the force you're applying. And this part of the graph is sliding or kinetic friction when the sofa begins to move. The point around which the sofa just begins the movement is called the breakaway point. Is there anything else you noticed in the graph? Why is this line at a lower level than the maximum static frictional force? The reason is simple. If you've ever pushed a sofa or some heavy object on the floor, you would have realized that pushing it is a little easier when it's in motion. Yes, it's because the sliding friction is lesser than the static friction that's offered by the floor. That was the concept of static friction for you. So we've seen three kinds of friction so far: static friction, sliding friction, and rolling friction. Can you place them in the increasing order of force being applied by each? Yes, static friction is more than the sliding friction, which will be more than the rolling friction. In all the examples we've seen so far, we've only considered friction between solid parts. Ball on a floor, box on a table, or roller skates on the ground. In all cases, both the objects were solid. Does friction come into play only when solid parts are involved? Is there any other kind of friction we haven't seen yet? Do watch our next video to know more. Let's say you have this cuboid-shaped box placed on the table. Try pushing it a little. You will require some force to push it forward. Now place this same box on top of cylindrical-shaped pencils and push it. What do you notice? You will notice that the force required by you to push it to the same point as before will be lesser. Why is that? Do the pencils reduce the friction between the box and the table? Absolutely. But it's not about the pencils, it's about the shape of the pencils. They are cylindrical. Assume you are traveling to another city and you are carrying luggage weighing around 25 kilograms. If you're unable to carry the bag, the only option you have is to drag it on the floor. But you will still require a lot of effort to drag your bag. But what if your luggage had wheels under it? Won't it be far easier to carry it around? Yes, it'll be easier. But the question is why? Why is it easier to roll a box over cylindrical pencils relative to pushing it on a flat surface? Why is it easier to carry the bag around when it has rollers under it? Hold on to this thought, I'll come back to it. Before we discuss the above situations, we need to understand what sliding friction is. The concept is simple. It is the frictional force which opposes the relative sliding motion between the two surfaces in contact. What does this mean in simple words? It simply means that if an object is in motion on a surface, the frictional force that is offered by the surface is called the sliding friction. The key words here are sliding motion. The two surfaces have to be in relative motion with each other. In our example, when a box is moving on the table, we say that the box is in relative motion with the table. The resistive force applied by the table when the box is moving is called sliding friction. Remember, the objects have to be in relative motion. Because there's movement involved, this force is also called kinetic friction. Now consider the example of the luggage in which we don't have the wheels under it. When we move the luggage, what will the resistive force applied by the ground be called? Yes, sliding friction. But what happens when we attach circular wheels at the bottom of the luggage? Yes, the friction gets reduced to a great extent. This type of friction which arises when an object is rolled on a surface is called rolling friction. It is a force associated with rotational movement. Now can you tell me by pure intuition about which force will be lesser? Sliding friction or rolling friction? Yes, rolling friction is usually lesser than the one associated with sliding friction. And that's why attaching wheels at the bottom makes it easier to move the object around. And similarly, moving the box on top of the cylindrical pencils is also easier. Can you think of more examples where the concept of rolling friction is used to reduce the friction? Yes, tires of your car. When the car is in motion, the ground applies a force of resistance which is nothing but rolling friction on the tires. Do you remember seeing ball bearings? They are spherical metal balls used in many mechanical structures which have moving parts. They're generally made up of stainless steel, brass or ceramic. They reduce friction to a great extent, which in turn reduces the wear and tear of machine parts. So we got the concept of sliding and rolling friction. There is another interesting type of friction which we need to know about. Will the force of friction come into play only when the two things are in relative motion? Not necessarily. To know which kind of friction I'm talking about, watch our next video. Does friction exist only between solid parts? Not necessarily. Friction is offered by fluids like air and water as well. And this force of friction due to fluids is referred to as a fluid friction. The friction we've seen between solid parts is referred to as dry friction. The major states of matter are solid, liquid, and gas. And liquids and gases are generally referred to as fluids. Why are liquids and gases considered to be fluids? One common characteristic of fluids is that they have no fixed shape and can be easily deformed. Let's discuss a bit more about fluid friction in this lesson. Just like solids, fluids too exert a force of friction when objects move through them. Do you think air offers resistance? Doesn't seem intuitive, right? When I drop a stone from a particular height, it falls to the ground. Does air offer resistance here? Of course it does. What about water? Does it offer resistance? Yes, when the fish swim, they encounter fluid resistance from the water. The frictional force exerted by fluids is also referred to as drag. What does fluid friction depend on? Let's talk about the first obvious factor. It's the nature of the fluid. To understand this point, you just need to answer a simple question. An object moves from point A to B through air, and in the second case, a similar object travels from A to B through water. Which object do you think encounters more resistance? Clearly, it will be the water, right? Yes, more the thickness of the fluid, greater will be the frictional force acting on an object which moves through it. There's a term which describes a fluid's resistance to flow. It's called viscosity. So here, we can say that the water is more viscous than air. Higher the viscosity, more will be the resistance offered by that fluid. Honey is more viscous than water, which is why it offers more friction than water. That was the first factor affecting fluid friction, the nature of the fluid. Can you think of any other factor? Another factor is the speed with which the object is traveling. Higher the speed of the object moving through a fluid, greater will be the frictional force acting on it. A vehicle traveling at 100 miles per hour will face more drag of air as compared to a similar vehicle traveling at 50 miles per hour. Apart from the nature of the fluid and the speed with which the object is traveling, is there any other factor on which fluid friction depends on? Yes, it also depends on the shape of the object. And it's really important that we understand this factor well. Have you ever thought about why aeroplanes are shaped like this? It could just have been a rectangular box flying in the air. How have the fish evolved to be shaped like this? Why are the ships designed to be given this shape? There's a reason for all this. They're given a streamlined shape to minimize the fluid friction. The shape of the aeroplane, if you notice, is like that of a bird. This process of giving an object a particular shape to decrease the fluid friction is known as streamlining. Streamlining the object can greatly reduce the resistance offered by the fluid. A car faces lesser friction from air as it has a streamlined shape. A bus, on the other hand, will face more air friction as it doesn't have a streamlined shape. So these were the different factors on which fluid friction depends. Nature of the fluid, the speed of the object flowing through the fluid, and the shape of the object.
We learned that friction is a force that resists motion whenever two surfaces are in contact. When the friction is less, the objects slip past each other easily, and when the surfaces are rough, the objects does not move against each other easily. Example, you need friction between your shoes and ice to walk on it. You need friction between your hands and lid of the jar to open it. You need grip between your hands and handle of the bicycle to hold it firmly. You need friction between your shoes and paddles of the bicycle to paddle it. And you need no friction between you and the slide to enjoy the ride. You need no friction between the striker and the board to play. You need no friction between the ball and the surface for bowling. Now let's learn advantages of friction. Friction is very important while driving a car. Without it, a car would slid off the road. On a dry road, there is a lot of friction between the car tires and the rough road surface. And in winters, there is snow or ice on the road. That makes the surface of the road very smooth, and there is little friction between the tires and the road, because of which the tires may slip off the road. This is why we need winter tires. Winter tires have special grooves to increase the friction in snowy and icy conditions. Friction also produces heat. When we rub our hands, it produces heat, which warms our hands. Friction between our shoes and road helps us to walk. Without friction, we will slip or fall. Friction helps to prevent the tires from slipping on the road because wheels need friction to have grip on the road and move forward. This is the reason the tires have grooves to produce sufficient friction. Now, let's learn disadvantages of friction. Friction makes it difficult to slide heavy objects on the floor. Every machine has several parts that move together or rub against each other, because of which a lot of heat is produced in the machine and damages the machine. Friction causes damage to the tires of vehicles. It also damages soles of the shoes and many other things. So friction causes wear and tear. Now let's learn how we can reduce friction where we do not need friction. First of all, for this, the moving parts of the machine oiled or grease, and this is done to reduce the wear and tear in the moving parts of the machine due to the friction. Fine powders can also be used to make the surface smooth. Example, before playing carom board, we sprinkle talcum powder on the board to make the surface smooth. So kids, now you know what is friction and what are the advantages and disadvantages of friction.
Friction. Another type of force that is oftentimes considered in the study of free body diagrams is the force of friction. This force occurs when surfaces slide or tend to slide over one another. Friction is a force that opposes the sliding of the surface across an adjacent surfaces. It acts parallel to the surface, and opposite in direction to its sliding motion. Friction can be favorable or beneficial. For fastening objects together, like the use of screws and nails, we need friction. Without friction, it would be impossible to walk. Also, brakes depend on friction. However, friction causes wear and tear on objects, and it reduces the efficiency of most machineries. Machines need to be lubricated to reduce friction, either by using grease or oil or sometimes by placing wheels. Friction is affected by two factors. One is the material's ability to form attractive forces that cause the two surfaces to stick together during a close contact, or the nature of material. The second pertains to how tightly the materials are pressed together, causing an interlocking actions in the irregularities of the surfaces in close contact, or the degree to which the materials are pressed together. An empty box can be pushed easily across the floor compared to a loaded box. The equation F equals mu times N relates these two factors, since mu as the coefficient of friction pertains to the nature of materials, and N as the normal force is the pressing force. When dealing with frictional force, the following must always be remembered. 1. Frictional force is acting along the surface of contact, and is opposite the direction of motion. 2. It is directly proportional to the normal force or the force pressing the bodies together. 3. It does not depend on the area of the surface in contact. 4. Provided the speed is not very high, sliding friction does not depend on the speed of motion. 5. Friction depends on the nature of the surfaces in contact. Two kinds of friction. Astatic friction is the force of friction present on objects in contact with each other, but are not moving. It prevents stationary objects from moving. Kinetic friction is the kind of friction that is present on objects that are moving. There are two kinds of kinetic friction, the sliding friction and the rolling friction. Kinds of kinetic friction. Sliding friction. In this type of friction, there is a resistance on the body's movement as only as one side of the body is in contact with the surface. Pushing a box across the table is an example of sliding friction. Rolling friction. The force resisting the motion of rolling body on a surface. Rolling of a ball or wheel on the ground is an example of rolling friction. Advantages of friction. Friction between pen and paper enable us to write on the paper. Friction between our feet and the ground allows our movements like standing, walking and running. Friction between the surface of the road and tires of our vehicles allow the vehicles to move without slipping. Disadvantages of friction. Friction causes moving objects to stop or slow down. Friction produces heat, causing wastage of energy in machines. Friction causes wear and tear of moving parts of machinery, soles of shoes, and etc. Methods of increasing and reducing friction. In real life, there are circumstances where we have to increase friction and minimize the friction. Friction can be increased by increasing the roughness of the surface in contact. For example, treading of shoes and tires is done to increase friction. When friction is undesirable, we have to reduce the friction. Friction can be minimized by using lubricants like oil and grease, and by using ball bearing between machine parts. A substance that is introduced between two surfaces in contact, to reduce friction, is called lubricant. Fluid friction can be minimized by giving suitable shapes to the objects moving in the fluids. Activity 2. Forces in action. 1. In these two pictures, the arrows represent forces acting. Write the names of the forces in the box. Forces in action. 2. Draw and label your own arrows on these two pictures to show the forces acting. Forces in action. 3. Draw your own pictures in these two boxes. Then mark in arrows and label them to show the forces acting.